Okay, our first job is to talk about Newton's second law problems with vector diagrams. Remember, vectors are just arrows that represent forces. We're not going to use all of the force diagrams like we've talked about, like normal forces and gravitational forces yet. We're just going to look at arrows that represent forces to start with. Well, the problems we did earlier had both Newton's second law and accelerated motion in them. They included F equals ma, force equals mass times acceleration, where we use force in newtons, mass in kilograms, and acceleration in meters per second squared. And we use the acceleration motion equations, where we had acceleration equals final velocity minus initial velocity over time. Distance equals 1/2 acceleration times time squared, remembering that that only works if the initial velocity is 0. And distance equals initial velocity plus final velocity over 2, the average velocity times the time. We used those before, and we had no trouble using those the other day. Okay. We're going to add a different wrinkle to that, the force diagrams, the vector diagrams. Okay. So we had all those forces. We have a 3 Newton force up, a 3 Newton force down, an 8 Newton force to the left, and a 13 Newton force to the right. Okay, you can see that the 3 Newton force up and 3 Newton force down are going to we're going to combine those together. Okay, and we're going to end up with one little force, right? And the net force on it is going to be 5 Newton net force, because the 3 up and the 3 down are going to add up to a net force of 0 vertically. And the 8 to the left and the 13 to the right are going to subtract against one another and give us a net force of 5. So that's going to make our total force of 5 Newton net force. And that's the one we're going to use in F equals ma. Okay. Then we're going to combine them together. Okay. Now, I'm going to read this basically. This is just like yesterday. If all the forces are given in the diagram, you're just going to find the net force by subtracting. Then, just like yesterday, when you're given the net force, you're going to use that to find the acceleration. Then you're going to use that acceleration in calculating the information, final velocity or how far it went, whatever the problem asks you for. Now, if you're missing a force from the diagram, you're going to have to use the information about the velocity or how far it went or how much time it took to find the acceleration. Then you're going to calculate the net force using F equals ma. Then you're going to work backwards to find out what that net force is. It sounds more confusing than it is. We'll do an example so you can see how that works. Okay, so we're going to start from the first problem. The first problem on your slide, this is a slide. First problem on your homework that shows on the Google Classroom. The mass of the block shown in the picture is 2 kilograms and starts moving from rest. So we're going to determine its acceleration. We're going to determine its final velocity after 2.5 seconds and how far it moved after 2.5 seconds. Okay. So first you can see in the picture that we're going to find the net force first before we can find the acceleration, because we're given all the forces in this problem. Well, you can see the force upward is 4 newtons and the force downward is 4 newtons, so those balance out. Leaves a net force of 0 vertically, so there's no net vertical force. But there is a net horizontal force because there's a 2 Newton force backwards and a 5 Newton force forward, so there'll be a 3 Newton force to the right. So if we can find our acceleration, now we have the net force. We take the net force, 3 newtons, divided by the mass, 2 kilograms. We get 1.5 meters per second squared. Makes sense, we found part A. Now we can go on to part B, finding the final velocity after 2.5 seconds. Well, the acceleration, like we got, is 1.5 meters per second from part A. We know our initial velocity is 0. And our time is 2.5 seconds. We can find all those from the problem above. It says moving from rest. That's how we get our initial velocity of 0. Our equation is acceleration equals final velocity minus initial velocity divided by time. I rearranged it. I'm an equation rearranger. Those of you who just like to plug in the numbers, you know what you want to do. So I multiplied both sides of the equation by time, and I added initial velocity to both sides, so I got acceleration times time plus initial velocity equals final velocity. Now I plugged in my numbers, 1.5 meters per second squared times 2.5 seconds plus 0 equals the final velocity. That ends up being 3.5 meters per second squared. And that's part B. Part C, because I know my initial velocity is 0, starts moving from rest, it says in the problem, I can use distance equals 1/2 at squared to solve for how far it goes. So I show the work for that. Distance equals 1/2, 0.5, times the acceleration, 1.5 meters per second squared, times 2.5 seconds, quantity squared. Remember, you're going to square that number first before you go on to the next one. Let's put all that together. You get 4.69 meters. This is the second problem that's on your worksheet. The block has a mass of 3 kilograms. It moves to the right from rest and reaches a speed of 3 meters per second in 5 seconds. Determine the net force on the block and determine the amount of the missing force. Remember, we talked about this one in the earlier part of the video. We said that you'd have to determine the net force on the block first by using the equations that described accelerated motion, and then we'd have to find the net force using F equals ma. So we're going to do that first. Like I said, we find it using the motion equations. Well, I'm lucky I have the initial and the final velocities and the time, so I'm able to use A equals final velocity minus initial velocity over time. I sub in my information. I use A equals final velocity is 3 meters per second. My initial velocity is 0 meters per second divided by 5. 3 minus 0 is 3 divided by 5 gives me 0.6 meters per second or meters per second squared. I can solve for the net force by taking 3 kilograms times 0.6 meters per second squared. My net force is 1.8 meters per second. Now I want the amount of the missing force. Well, I know it's got to be more than 1.8 because it wouldn't go forward in that direction if it didn't have a force greater than 1.8. So I said, well, if whatever the missing force is, minus 3 gives me 1.8, then the missing force has to be 1.8 plus 3, or 4.8 newtons. All the problems are somewhat like that. Some of them are in one direction vertically, some of them are working horizontally, but they're all going to work in roughly the same way. So take a look at the questions that are on the Google Classroom. That should be enough to get you going in that. Good luck.